Okay, so here's a wild thought. What if I told you there's a hidden, kind of mind-blowing connection between a math problem from like 2,500 years ago and the super sharp 4K screen you're probably watching this on right now? Sounds crazy, right? Well, today we're going to dive into the geometry of reality itself. So let's just kick things off with a big question, kind of a paradox, really. I mean, we live in this age of just incredible visual clarity, right? Our screens are more detailed than we could have ever imagined. But is it possible that all this perfect, crystal clear resolution is, in a weird way, making us blind to what actually matters? This really gets to the heart of the trade-off we're all making, whether we realize it or not. Think about it. On one side, you've got your imagination, firing on all cylinders, actively working to fill in the gaps and build a world inside your head. And on the other side, you've got high fidelity, a screen that just delivers a perfectly pre-packaged world right to your eyeballs. We're basically swapping out creation for consumption. So yeah, this is what we're going to call the fidelity paradox. It's this really strange, counterintuitive idea that the more perfect and realistic our media gets, the less our own brain has to do. And the less our brain works, well, the more passive we become in the whole experience. And if you look at this from a biological point of view, it gets even more interesting. Our brains are, they're absolutely incredible pattern recognition machines. We're literally hardwired to spot the tiger in the tall grass, right? That's what kept us alive. So what happens when our world is so perfectly rendered, so high def, that there are no meaningful patterns left for our brain to find? All right, now the key to unlocking this whole modern day problem, you're not going to believe it. It lies in an ancient geometric puzzle. Yeah, something every single one of us had to memorize in school, but let's be honest, probably never really understood. Yep, you guessed it, the Pythagorean theorem. A squared plus B squared equals C squared. We can all chant it in our sleep, right? But the real magic, the secret sauce, it isn't in the A, B, or C. It's in those little number twos. It's all about the squares. And this, right here, is the question that unlocks the whole thing. Why squares? Why do we have to square the numbers? Why can't we just, add the lines together? Why isn't it just A plus B equals C? It feels way more intuitive. But trust me, there's a really, really good reason that's completely wrong. Okay, so to crack this puzzle, we have to kind of rewire our brains and think about numbers in a totally new way. Instead of just seeing them as simple lengths on a line, we need to start seeing them as dimensions of growth. So, check this out. Here's a cool way to think about exponents. N is just your starting point, your raw material. In this case, a simple line. Now that little 2, the exponent, think of that as the growth pace. It's an instruction. It tells that line, hey, expand in a whole new direction. And boom, it creates a two-dimensional square. And that number out front, that's easy. That's just telling you how many of those squares you're working with. Okay, so let's apply this new thinking to our triangle puzzle. If we use that simple one-dimensional logic, just adding the lines, the whole thing falls apart. It just fails. Imagine you walk 3 miles east, then turn and walk 4 miles north. In total, you've walked 7 miles, right? The shortcut back to where you started, that's side C. Can that also be 7 miles long? No way. A shortcut by its very definition has to be shorter. But watch what happens when we start thinking in 2 dimensions, when we apply that growth pace. A square built on that 3-mile side A has an area of 9. A square built on the 4-mile side B has an area of 16. Now what happens when you add that territory together? 9 plus 16 is 25. And that is the exact area of the square you can build on the shortcut side C. The math just balances out perfectly. And that's the big reveal. The theorem isn't really a formula about lines at all. It's a formula about territory. The math only works when you're comparing apples to apples, or in this case, 2D space to 2D space. Okay, that's a neat math trick, but what in the world does this ancient idea of territory have to do with the phone in your pocket or the screen you're staring at? Well, turns out it has everything to do with it. Let's build that bridge right now, from Pythagoras to pixels. I want you to picture a perfect circle on a super high-res 4K screen. Here's the secret. It's not a circle. It's a beautiful lie, a total illusion. What you're actually seeing are millions upon millions of tiny little squares, pixels, all arranged so cleverly and so close together that they trick your eye into seeing a smooth, perfect curve. So instead of using an elegant, simple geometric idea to draw a circle, our modern tech just uses brute force. It's like it just throws an insane number of tiny data points at the problem until it kind of looks right. We've traded the elegant, simple solution for just overwhelming computational power. And this is where the story takes a turn. Because this big shift, away from elegant geometry and towards brute force data, has had a really profound and, frankly, pretty damaging effect on our minds. It's created something the source material calls our brain's parasite. It's a concept called parasitic potential. And what that means is it's basically an evolutionary mismatch. Our brains came equipped with this amazing, super powerful tool for pattern recognition, to survive. But now that very same tool is getting hijacked. It's being co-opted to analyze completely meaningless, high-fidelity data for no other reason than, well, just because it's there. I mean, just think about the contrast here. It's wild. The problem our brains evolved to solve was life or death stuff, like, is that a tiger hiding in the grass? The problem we're giving it now is that one pixel shimmering the right way? We're using the exact same high-powered tool, pattern recognition, but the outcome? It's gone from actual survival to just sensory gluttony. And here we are right back where we started, full circle. We are actively trading our imagination for passive consumption. Think about it. A blurry, low-res image forces your brain to get involved, to fill in the blanks. It's an active process. But a perfect 4K image, it delivers everything on a silver platter. It demands nothing from you, except that you just sit there and watch. Your brain, which is the most powerful graphics card in the known universe, is basically being put on standby. And this all leads to a really profound and kind of sobering final thought. We're getting so obsessed with the superficial details, with the graphics of the simulation we're watching, that we're completely ignoring the real-world consequences. We are literally sitting here analyzing pixels while our actual hardware, our bodies, the planet itself is, overheating. So I guess that leaves us with one last really critical question to ask ourselves. In this constant quest for perfect clarity, for ever higher fidelity, are we just optimizing for better and better resolution instead of looking for the real solutions we so desperately need?